Okay, so we are all set with this YouTube thing, and then let's start with the lesson. I'm pretty excited to be your guide through this modern C++ course this year. It's gonna be a bit challenging since we never did this before, like doing these online lectures. But I think it's going to work out for both for you and for me as well. So this year, because of the coronavirus thing, we can't teach you C++ on the classroom, but I feel like this is good news for everyone, because I never felt like teaching coding on a classroom. So it's quite difficult. It's like, for me, it's like if I would be trying to teach like 10 people how to ride a bike in a classroom. So it's quite challenging. So of course we can explain some theory facts and some ideas, but maybe the most important thing is that you need to get your hands on the keyboard and start coding. Okay, so let's get started. Let's discuss a bit about the course organization. So we will have like lectures every Wednesday at 4 p.m. on Central European time. So this is in Germany. So this is basically this lecture. And this is going to be once a week. So every Wednesday I will be trying to give you a lecture of not more than 1 hour. That's my idea. So you commit yourself, you put effort, 1 hour, and then you learn something. So we have lecture videos that I will point you with the link. But the thing is, why I'm sorry, I need to check the chat. Okay. I'm sorry, guys, I'm not a YouTuber. Okay, great. Why I don't want to do this offline video thing? It's because I want to give you guys the feel like you are going to the university. So that's why also some of the colors of the layout of the video. So the idea is that you commit to go to lectures every Wednesday at 4 p.m. Of course, I need to put extra effort to do this, and I expect that you also put extra effort during the homeworks. So this is going to be like 10 lessons where I will try to explain you, guide you through the topics and do some live coding examples. And then we have tutorials every Friday, but this is not going to be like a lesson where I will not be doing this live stream thing, but I will be basically online on the Discord channel. In case anyone has any question, we can discuss it through there. Also on the Discord channel, I can share you my screen. So if there are like some question, I can say, okay, let me share you the screen, and I will show you how to fix some issue or wherever. And also you should reserve this spot for yourself, because I will be giving you videos that I will be recording myself, and also videos from other people that you should like watch to these videos on this time slot. And then if you haven't already, just please sign up to the Discord channel. So this is the fastest channel to discuss for many reasons. Please, if you have a question that you think that someone else might benefit from the answer, just ask on the channels. So we have a lecture channel to discuss stuff about this. For example, you say, I hate this YouTube live stream, it doesn't work for me. Then you go to the lecture channel on Discord and you say, hey guys, what do you think? Do you think we should use Zoom? It's like this other guy is using Zoom, it's much better than this YouTube live stream. Wherever. If you have any issue with the homeworks, you will go to the homeworks channel and say, I'm starting with homework number 2, blah, 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 blah. And then we can discuss everything there like as a group. And this will allow me to give you one answer for all of you guys. And of course, I am working from home, so I'm basically always online. So if you are struggling with something and I am online in that moment, I can help you to sort the issue. Just be aware that I'm currently in Argentina, my home and lovely country, and there is 5 hours difference with Germany. I have no idea where you guys at, but with Germany there is 5 hours difference. So make sure you sign up to the Discord channel. Okay, this is for me important for you because this is some numbers that not everyone see. If you look to the study plan of this course, you will have these numbers, and I did the math for you. And then let's try my new magic tool. Okay, apparently it's working. So in this particular year, this 60 hours per semester on lectures, this is more or less the time we spend during doing lectures during a normal semester. So in this case, you will have to spend these 60 hours in the whole semester with my YouTube videos and other recommendations I will give to you. And then if you do the math, you will have basically 8 hours a week. What is the meaning of this? Is that at least you need to spend one full day working on the C++ homeworks, plus the lectures and the tutorials and whatever. So if you want to make a schedule for yourself, you can say, okay, every Thursday I will work from 8 AM to 5 PM on the C++ homeworks. Depending on the background you have, if you knew C++ before or whatever, you will probably need to spend extra time. But this is basically the minimum requirement. So it's very unlikely that you get through this course just spending 2 hours a month. So it's 1 day per week for the C++ course. So what are the basics that you will be learning in this course is how to work on a Linux environment. This is super important. How to write software with modern C++ and some core software development techniques. So this is not a programming course, it's not a pattern course, so it's not going to be sufficient if you want to learn this, but we will discuss some small points. And also we will be dealing with OpenCV, that is an open source library to work with images. And then the final project is basically doing this inverse image search that you can check that link. That is basically to see a working example, but we will adapt this idea and try it on our field, that is the robotics field, and we will build a place recognition pipeline, sort of, using inverse image search. Okay, this year I also spent some extra time trying to sort the contents of the course to make it easier for you. This doesn't mean that it's extremely easy, but I spent a lot of time trying to make put the topics from the easiest to the hardest. So if you see this is the schedule, so all this information is on the webpage of the course. So you can go and check it out, but it's basically in 4 parts. So the first part is basically the tools. So this year I decided to completely remove whatever is related with tools from the lectures. This means that I will not be discussing how to build a project during the lectures, because that's not the key concepts of the class. But then we will move this to tutorials. So all the first part, that is basically how to build projects, how to use Linux, and all this part will be part 1 of the course, that is basically the tools. So this is the tools you need to know in order to work with the concepts, right? But then the concepts also need like their own place in the course. So then we have 2 extra parts, that is basically part 2. I call it the C++ core language, and it's basically 4 weeks. This means 1 month. Then if you complete this part, let's say, there is no real examination between parts, so it's just like a scheme to make it easier for you. So if you complete part 2, that is the core language, then you will probably know how to code in C++, stuff that you already know how to code in other language, like let's say Python or MATLAB. So it's basically the core language is what I call like what you can do with other languages as well in C++. And then the third part is going to be the modern C++, that this is the meaty part of the course, that is basically, don't mention Java in my course. I'm watching the chat. The modern C++ part is the meaty one, I was saying. That is the things that you will be able to code in C++, but you cannot code in other languages, or it's the most fancy part of the course, I would say, and also the most complex part. In previous year, we used to explain some of these topics around the semester, but this year I tried to make it like from easy to hard level when I made the schedule. And then the final part is going to be the final project. That is this, basically you will have one lecture on the concepts behind the final project you need to implement, and then you will have no lectures because you need to do the project yourself. And also one thing we are doing this year, so you don't complain, there is a lot of homework. Some of the homeworks during these 9 homeworks will be related to the final project. What is the meaning of this? So if you complete, let's say, homework number 5 and you do it properly, then you have 10% of the final project already done. So I will not recommend you to do some stuff that I know students do. That is like I do the 50 points and then I quit until the final project, because during the homeworks you will be also implementing tasks from the final project. So this will give you the ability to complete this final project in less time. The course content, so this is basically the topics. This you can also check on the webpage. I just put this on the webpage for people who is curious and wants to know what we will be learning during this semester. Then the philosophy of this course, and for this I will ask you to help me, is that this famous quote that is say, "Talk is cheap, show me the code." So sometimes in coding, not in C++, but in every language, so people can spend hours talking about like one particular thing, but then when you see the code, it's super simplistic, and then it's faster to just see the code and discuss about the code without like too much talk. So that's the philosophy. This is what I expect you to do in this course. So you should get your hands dirty. You should be hours on the keyboard trying stuff in order to make it work. So you will get your hands dirty. And then I have a disclaimer here, that is that I will ask you to stop me if you don't understand anything, but I also need to ask you that don't be surprised if I do something fast. It's not because I am smart or because blah blah. It's because I have been using Linux, for example, for more than 10 years, so I am really used to this, and sometimes for me it's really difficult to not do the stuff I'm used to do. So if you see that I did something funky, you say, wait a moment, I have no idea what you're doing, you just open this, but blah blah blah, just go to the chat and say, Nacho, stop, what are you doing? I will try to go slow, but I am really used to type on the keyboard, so I might be a bit fast, but this doesn't mean that you should be scared or say, oh, why no, this is like so complicated, he's doing it really fast. It's just because I have been doing this for 10 years. So make yourself, so I want to make this clear. And also, I usually try to use like modern desktop environments to show you how to use Linux and wherever, but currently I only have a dual core machine and it's 5 years old, so I cannot run like really heavy desktop environments like GNOME or Unity, wherever. So I am running a tiling window manager that is called i3, and if you see it, it might be like hacky or whatever. I don't recommend you to use this, but I just want to mention that you can make your computer look much more beautiful than my computer. So don't be scared for that. Why? So I also made frequent questions and answers on the Modern C++ website. I will recommend you to go there and check it out. It's on the website. You go to the FAQ tab, and then there you have the answers. But then here I will try to motivate you to why you should use C++. I know that some of you only want to know C++ because it's part of your study program, but believe me, it's a really fun topic. it's a really fun language when you learn it properly. So when I was designing this part of the class, I wanted to show you millions of things of why you should learn C++, but then I decided to make it more simple and then encourage you to go and look on Google, YouTube, whatever, why you should be learning C++. So before you start learning, you should ask yourself this question and then do some research on the language itself. So this is from 2018, but here are some of the numbers of the survey from Stack Overflow. So most of you might already know Stack Overflow. So it's basically a forum where people ask questions about coding. And then every year they do this survey where they ask like most of the programmers in the world, let's say, which tools they use, which environment they use, and whatever. And then the results from some key results, because it's a big survey, I would recommend you to go and check it out, is that nearly half of the people who are professional developers are using Linux as the primary system for working. And then this was in 2015. C++ was the most used system language with almost 5 million users. So C++ is still super popular. Nowadays we have all languages that are a bit more popular, like Python, let's say, but this is also because Python can be used for more people. But then you need to keep in mind that we are trying to target C++ for robots. And then if you go for robotics, the robotics field, then you will not find like many Python or whatever other languages working there. So make sure that when you see these surveys and comparisons, make sure that you know what you're checking, because of course you will see, I know JavaScript, like the most used language, but everyone is doing web development. So it's not really fair if you trade it against JavaScript, because it's a different monster. So all of the companies in our field will want you to know C++. And also if you don't plan to go for the industry and you plan to do research, it's really important that you know C++ in terms of it's really good if you can run experiments and don't need to wait like for 3 months in order to get the results of these experiments. So with C++, it's not the best language for prototyping, but once you have the ideas, it's really fast. So one of the key ideas of C++ is that it's super fast, and this is why we use it in our field. Another reason is that nowadays, so maybe 10 years ago when people were talking about, okay, let's save a few bytes of memory, people start laughing because it was the age where people start getting like 12 gigabytes of memory RAM on the computers. But then the game changed, because then the computers stopped being only on your desktop and then started to be on your smartphone, on your watch, and on your robots, and everywhere. So then the power consumption and the footprint of the processors you put on these devices start, so the weight of these start to matter, and then people stop laughing about like memory efficiency and all this stuff. And this is why still C and C++ are one of the most popular language out there. Not because you want to save like time on your desktop machine or memory on your machine, but because you want to probably run this software in embedded devices where you don't have like infinite amount of resources, and then every bit matters here. And even when you say, I don't care, I have money, I can pay more, like a bigger processor, whatever, then you will need to pay energy consumption, and then you will need to put a bigger battery on your device. So this is where the trade-off, like you say, you could stop, and then this is where like compiled languages like C or C++ start to have really importance. These are some of the companies that I know they use C++, so it's not like a weird language that no one uses. So Google, Microsoft, all of them use C++. This doesn't mean that they use C++ for everything, but we know for a fact that they use C++, and also they are part of the people. So they have people who invest time on making C++ a better language. Some browsers that use C++, Firefox, Chrome, if you check the source for these browsers, they are all written in C++. Also, there is some software that is written primarily in C++, like the Java virtual machine, some part of the Windows operating system, Office, Photoshop, many of them. And there's also a big part of the game industry that uses C++ as primary languages. So this is one of the some games that we know that are written in C++. Okay, so let's see a bit of history of C++. So basically, when we start having computers on our life, we have this beautiful language I love that is called assembly. And one of the benefits is like there are really simple instructions for this language to program computers, and it's super fast when it's well written. And then you will have complete control not over just your program but also the hardware. And then if you check these benefits, you will say, okay, this is the language we should be using as humans to program computers. Why don't we use this always? So let's check how the Hello World example looks. So this is a program that you need to run or write in assembly in order to write Hello World to your screen. So of course it's quite difficult to read, and it's not straightforward like what it's doing when you see the program. And then you will have a lot of code to do really simple tasks like this Hello World. It's really hard to understand, and the thing about assembly is that it strictly depends on the processor you are targeting. So the assembly language will be different from AMD processor than Intel processor. So this is one of the biggest drawbacks. And that's why people came up with the idea of getting a better language like C. And then they say, okay, so computers will only understand assembly. And then this is actually not extremely true. Computers only understand binary code, but assembly is really easy to translate to binary code. And then the idea is like, why don't we write code in a more intuitive language, and then we add an additional program, that this program we will call the compiler, that transforms this source code on the high-level language to assembly language. And that's how they came up with C. So these are Cunningham and Ritchie, the creators of C. This happened in 1972, so a long time ago. And then they made this language that was super fast, simple, and cross-platform. So you don't need to know your architecture anymore. And then C was super popular because it was easy to use, but also was part of the weakness of the language. So they didn't have objects or classes. It's difficult to write code that worked generically, and it's super tedious nowadays still to write large programs. So C is still one of the most used programming languages out there, but my expectation is that people start to move to C++ just because it's a better language. So then this guy called Bjørn Storstrup, there is a Danish guy, super cool guy. 40 years ago, he invented the C++ language, where he wanted to take all the benefits from C, like it was fast, cross-platforms, easy to use, but add more high-level semantics into the language. So he wanted a language that was super fast, simple to use, and cross-platforms, but with high-level features, like using classes, objects, generics programming, and so on. And this is basically the full story of C++ up to today. So there is also a question on the website about what is modern C++ and what is not modern, but basically we will say that whatever is after C++ 11, that is basically the standard that came after 2011, this is what we call modern C++. I mean, if you use language features from these standards, and wherever is before C++ 11, we will call just C++. Particularly in our course, we will be using this standard that is C++17, that is a standard that they released on 2017 and has a lot of modern features as a language. Nowadays they are still working on the C++20 standard, but this is not, as far as I know, they will release this in 2 weeks or so. But we will not use C++20 features because they are not fully supported in compilers. So the design philosophy of C++ is basically to be multi-paradigm, and this is not only to be a object-oriented language or a procedural-oriented language, is to support different paradigms and then express ideas and intent directly in code. So this is super important for me because probably some of you learn how to program using C from other language, where in these languages, when you want to express ideas in code, it's really difficult. So how people sort this problem with comments. So up to, I know, before C++11, let's say, people were like super fun on like putting comments everywhere. This was the default. So comment your code because blah blah blah. And then people started to think about it, and they say probably it's better that if your code is easy to read, then you need the comments. And then if you have like a really hacky instruction that no one can read, and then up this instruction you need to put like 50 lines of comments, then it's probably a bad idea or a bad design. So for us it's really important in this course that you try to express ideas and the intent of your code in the code and not in the comments. And C++ will give you the tools to do this. And this is why C++ it's a better language, modern C++. Also, C++ will be super safe when used wisely and will be extremely efficient. And then will give you the abstraction layer that we call this zero cost abstraction. That is basically use some high-level features of the language without paying the price at runtime. This means your program will run slower, or at memory footprint. This means your program needs more memory. And then about efficiency, so still nowadays, sadly, a lot of people argue that C is faster than C++, and most of these people is because they don't know how to use C++, and they are not probably using the right tools or the right compiler. So it's extremely difficult to beat C++ in terms of efficiency when you use wisely. So make sure you keep this in mind, C programmers. Okay, so this is part of the tools. Like we will be using GNU/Linux distributions on this course. I will give you a brief introduction here. So if you have any questions, it's the moment to write it in the chat. But basically, this is not part of the core lectures, I want to say, but because the first thing you need to do is to open a terminal and start doing stuff, then I need to give you kind of an introduction on GNU Linux. Of course, my recommendation is like go check on YouTube videos, Google why should I be using Linux, why Linux is better, why Linux is not better than Windows or Mac OS, whatever. So usually if you try to ask me why I use Linux, you will need about 2 or 3 hours if you want to really listen to my answer. So, but my recommendation is start using Linux. Your life will be much better. The only drawback is that whenever you use any other operating system, you will not believe how people is using this. For me, every time I use Windows, I want to kill myself and cry because I cannot believe that most of the people in the world in 2020 is using Windows. We have a question. Using C++17 mean that we need to do something else that we did from the repo tutorial? No. So actually, the standard is just a convention, let's say. So you installed a modern compiler so if you follow the first tutorial, a modern compiler that supports multiple standards, sorry. So with this compiler, you can say, okay, build this program with C++ 11, and with the same compiler, you can build this program with C++ 17. So it's just a standard. So it's not all the compilers support all the standards. So if you're using, for example, Ubuntu 18.04, they have all compilers, so they don't support C++ 17. So they have some features, but not all of them, like the file system library, that is super important. And that's why I ask you to install a modern compiler that supports this standard. But the standard itself, it's actually not visible to the programmer always. So you just say, whenever you compile something, you say, use this standard, and then that's it. So Linux is a free and libre Unix-like operating system. So it's inspired on Unix. This started like also 30-40 years ago. So if you use macOS and you're used to use the terminal, then you will find some similarities. So why we say GNU/Linux is because the Linux kernel is just a small part of the operating system, and the rest was provided by the GNU project. So make sure you go and check it out why we need to say this. And then nowadays it's extremely popular. So when I started using Linux, I was a geek and people were looking weird at me because I was using this weird thing. But then Android became super popular, Chrome OS, and then nowadays most of the servers are running Linux. When I say server, I mean like big computers out there. I know that even Microsoft, for this Azure platform, they are running servers that run Linux. So this is super fun for me, and I'm glad that Microsoft accepted this fact. So there are many distributions available. You can use the one you want, of course, but I will be providing just support for Ubuntu because it's the most easy to use distribution, and it's the one we use on the course, and it's the operating system I'm running right now. So this is how the Linux directory tree looks. So it's super simplistic and there is no hidden stuff. So we don't have these letters C, V, wherever, and everything starts from root. That is basically the root directory is like the very first directory of the operating system. That is basically this guy here, and then hierarchically all the other directories or folders, call it as you want, are inside this root directory. Of course, what is the meaning of each of these folders? It's complex to explain and will take a lot of time. Usually, the only thing you want to know is that there is the user space folder that is on / that is root, home, and then this will be your username, that in my case is Vizzo. So this is basically where you will be working with your files. Then the folders in Linux will always end with this / character. Let's use this guy. Oops. So any folder, so any path that ends with this character will be a folder. So here's one example, and then everything else. So if you don't append the /, then it's going to be a file. So I know what is this, but I know for a fact that this is a file. Then absolute paths will start with the /, and then all other paths will be relative. So what is the meaning of this? That I have all my files on my home directory, that this is on /home /Vizzo, and then /whatever folder. And then, for example, I have a file there that is called file.cpp, and this is the full absolute path. But then, for example, I can be working on this directory called folder. And then when I say folder /file, then I mean like from here, go to folder, and then the file. So this is why we call it relative path. And then make sure that you know that paths are case sensitive. So it's this file name from here is not the same as this guy, so these are completely different names. And then the extension is always part of the name. And this is something that is super simplistic. So here the extensions are not obscure like in Windows, where you cannot, like, you need to go to the properties. So I never got this in Windows how to do, but here in Linux, the extension of a file is part of the name. So it's basically part of a string, so there is nothing weird. If you want to change the extension of a file, then you just rename it. You don't need to do anything else. So this is super simplistic and it's good. So this is your best friend when you use Linux, is use the terminal. Most tasks can be done much faster from the terminal than a GUI. I am a terminal geek, and this means that I really like to use the terminal to get my stuff done super fast. And then if I need to use the GUI for some reason, it's usually slower and I prefer to move fast. So make sure you press Ctrl-Alt-T on your Linux distribution and open a terminal and try to do stuff from here. Probably if you're starting to use Linux, my recommendation is that don't try to do the stuff you're used to do in other platforms, but try to Google how to do it from the terminal. And this is how you get up and running on the terminal, and this is how you learn how to use it, basically. Here are some commands to navigate through the terminal. So basically, if you do print working directory, okay, let's see if I can bring up a terminal here. And then no. Okay, then this cannot win. Let's do this thing, and then let's open a terminal to the right, and then let's see. I think you can see from there. So basically, this is my terminal. I made it look clear so it matches the rest of the colors. So if I hit here print working directory, you will say, okay, you are working on /home/Vizzo. And then if I want to go to any directory, I can do for example cd and go to documents, for example, and I am this is how you change the path of your system. And then, for example, if you want to list the files that are on this particular path, you should do ls. So this is the most simplistic commands you can find out there. Then this is how the commands are structured. So basically, I don't really like this idea of commands, because there is no such thing. So a command is basically a program and that's it. So it's not that there is something else. It's just a program that someone built for you and you have it on your system. So whereas this is basically on the path. So this path is it's a variable. So this guy here. So if you open the terminal, you will see that actually, let's do it. So if you do echo, for example, this is to inspect a variable, and you say path. This is all the directories where whenever you run a command, the shell, that is the terminal I'm running, will go to this directory and search for the program. If it's not there, it will go here or here or here. So basically, that's all the magic behind the commands. There is no such thing as commands, but because of this path variable, it gives you the ability to run the programs without having to specify the full path. So you don't need to do /user/bin grep, that is a command, but you can just do grep. Basically, these programs will always have, or usually will have, options and parameters. If you want to know what a program does, just use manual or do the help. By the way, all these slides will be available on eCampus on the site. So some stuff I will try to not be explaining, like how to run a manual, because it's not fun at all and you can do it by yourself. but it's on the slide because it belongs to this particular topic. So I wanted to put it here so you can download the slide after the lecture and try to run this on your computer. Here is an example on how to do completion. So this is something I recommend everyone to use. So especially when you start running Linux, when you press tab, the shell, that is the terminal, will try to autocomplete what you're doing for you. So some people just try to write like really long commands, and then they press enter and say, this doesn't work. But then you have like, I don't know, like you're trying to execute a 50 characters command, and then you don't know if you have a typo. So the best way to do this is to, like when you are typing, just press the first, just type the first letters you want to type, and then just tap. When you do tab, you will get an auto-completion, and this is much easier for you because if the terminal is doing the auto-completion for you, this means that whatever comes after the auto-completion, it's right. So you're sure that your command is working. Here I put you like a brief of the commands you need to work with files and folders, like how to create a directory, how to remove a directory, how to copy a file or move a file from one place to another. And one thing I will recommend you to do is to, after this video, go to this placeholder slide, and there is a small exercise here, and that's basically in how to use these placeholders. That is basically special characters that will give you ability to work with files easily. So I will just mention one example, and then this is my shell, and then let's say that I want to list all the PDF files that are in here because I want to see the names. So basically, if you see here, this is my full path. So I am on home, student, examples, placeholders. And then if I do ls, I am watching all the files that are in here. And then basically when I do ls star.pdf, this star means like give me everything, whatever you want, but with the .pdf, I'm saying just give me the ones that ends with .pdf. Of course, you can do a lot of combination with this, and then you can do regular expression, but we will not see this on the course. But I would recommend you to go and check it out, this example. And then lastly, about Linux, I decided to explain this maybe really fast, because I know a lot of people struggle with this. And it's super simple, and once you see it, you have this idea on your mind, it's really simple to follow. So basically, whenever a program is running in Linux, the Linux kernel will assign 3 file descriptors. You don't need to know what is that, but you need to know that you will have a standard input channel, that is this guy here, that we usually call it STIN. And then you have 2 output channels that will be standard output and the standard error. Usually when you print, I know, hello world to the monitor, you're basically sending this string to the standard output channel. And then the kernel reserves 3 file descriptor numbers, that is this guy here, this guy here, and this guy here, for these 3 particular channels. What is the meaning of this? Is that when you run this program, basically what is running behind the scenes, that is this program is taking the standard input from the keyboard, unless you specify something different. This is the standard, the default configuration, and then the standard output will be printed to the monitor and the standard error as well. So let's check out an example of this. And then for this, let me open another terminal here, and then okay, so let me change this size, and then no, not you. Okay, I think this looks good. Okay, we're done. So basically, I will show you how is the workflow of these standard input and channels using a shell. So I have a directory here on my home directory. So I'm basically, right now I'm /home/Vizzo, and then I know I have this examples directory, and now I will press tab. So if I press tab on my shell with autocomplete, hitting enter, I will go into this directory. And if I do ls, I will have one binary file here that is called program, because it's the same as the example. Then if you do clear, you will clear the screen of the terminal. Now how to run this program, just do /. This means that from this directory, run this program. Of course, you can autocomplete, this means tab, and then you just hit enter. And then on the standard output, you will see this message that says, please enter a number, let's do 8. And then on the standard error channel, you will have this error that the given number is 8. What is the meaning of this? Is that basically the keyboard, by default, it's going through the, I don't like this yellow. The keyboard is going directly through the standard input of this program, and then the standard output will be printed to the monitor and the standard error as well. So this is the really basics of how a program works with the inputs and outputs of a program. Now let's see how to start redirecting this, and I will show you probably one example from this thing, and then I will point you to a tutorial where they go deeper into this, and I highly recommend you to watch this video. The one I will recommend you later on, because it's just 10 minutes, it's well explained, you learn it fast, and it's simple. Then let's say that for some reason I want to redirect the standard output of this program to a file that is called cout.txt. How I do this? So this is the syntax, so this is not something we can change, but it's basically program, and then you say 1, and why I say 1 is because the file descriptor for the standard output is 1, and then you will say, okay, please put 1 into this file called cout.txt. And then basically what is this going to do is like it will redirect the standard output to a file, and this means that you will not see this anymore on the screen. How you can check this? Just do program and then you say 1, and then you just do cout or the name of the file you want, and then you just hit enter, right? Then if you remember, right now we should be seeing this standard output, please enter, give me a number, but because the standard output is now being redirected to a file, you cannot see the output. So let's put 66, and you see here an error message because the standard error is still being redirected to the monitor. If you list the files here, you will see that you have this cout file, and then if you inspect this file, you will see that you have this standard output, please enter a number. So that's all you need to know. Basically, you have many other things you can do here, like for example, redirecting the standard error to a file, or doing both. My recommendation, download the slide, check the examples. It's really useful for you. And here I put you like some of the commands you need to know. So this is a must. It's like 3, 4, 5 commands that you need to know in order to work with Linux, otherwise you will struggle. Then when working with the shell, you can also run multiple commands, and then you can change these commands. So one option is to use the semicolon or the ampersand. This is super easy. It's basically you have 3 commands you want to run, and for example, in this case, this means run command 1. I don't know what's happening after this command 1. I don't care. Just run the command 2 after all, and then command 3. So that's what this syntax is doing. Then this other syntax that is actually super useful is like the double ampersand. Is basically run the command 1 and then run the command 2 if the first command succeeded. What is the meaning of this? If command 1 gives you an error, then you will abort the complete thing. And then about piping, so piping itself is a topic on when you work with Linux, but basically if you remember these examples, for example, so whenever you say, okay, the keyboard it's feeding to the standard input of a program, when you do piping, you're basically, in this case, so the standard output of command 1 is being fed to the standard input of the command 2. And that's why it's like a pipe. So the output of command 1, instead of being printed to the file or the monitor, you are injecting this standard output to the standard input of our program. So basically, if you go to this guy, this example, so let's say if you remove this, then this is where the standard input will come when you do piping from another program. So you're not taking the input from the keyboard itself, but from the output of another program. And basically, if I would recommend you, this is the video I was mentioning before. It's basically 10 minutes videos on how to work with pipes in Linux and redirection. Make sure you go and check it out. 10 minutes, you learn it, that's it. It's super easy. You should not struggle with its small details. Okay, and lastly, I am putting here a link to a bash tutorial. So bash is the terminal you will be using most likely, but if you install Ubuntu and then you open a terminal, you are using bash for sure. And this is a bit longer, so it's a 1 hour video. But the thing is, if you spend 1 hour in this video, my guarantee is that you will learn all the stuff you need to know about bash. So for this particular week on Friday, so this is your task. You need to watch this video and you need to stop so you need to watch the video on YouTube and then have a terminal at the side. And then you stop the video whenever you say, okay, this is happening, and then you run the commands, and this is how you get used to the terminal, and this is how you learn. So that's your task for this Friday. Just check out this video. Their video is optional, the one from pipes. So this is optional. It's also highly recommended. But the task for your Friday is to make sure you check this video and go through A to B. It's 1 hour. It's all the things you need to know. Any questions about Linux? So this was a super short introduction on how to work with the terminal. Like really short, really fast. The only way to learn how to do it is using the terminal. So there is no black magic, no funky stuff, nothing. Just go open the terminal, use it. There is nothing really bad that it can happen from a command that is run on the terminal. Okay, so what is the difference between standard error and output channel? Okay, so there is no real difference. Let's put the picture here. The thing is, actually on the 10 minutes video I point you out, there is a good example of why you want to have separate things, but it's basically to split the water and say, okay, I will have a standard output where I will print like message that they are not really important, but I also want to have control of this and print error message to another channel. And for example, if you write a program with this example where you have a file that is, so this file will have the content of the errors of your program. So this is something that you might want to do, and this is a matter of flexibility. If you will have, you can have one channel if you want, so the Linux kernel could be built this way, but then whenever you have you will have all mixed like outputs with errors all on the same channel. Other thing you might want to do is this example. Let's say you're running a program and this program is printing a lot of information like debugging, a lot of stuff, and then in the middle of the program you know that there is an error, but then you cannot see because it's like you have like 50,000 lines of messages, and then you say, okay, I will redirect the standard output to a file, because I don't want to see this now, I can see this later, and I only want to see the errors. And this probably, instead of like having 50,000 lines of debug information, you will only see the errors, like error, like this is happening. And this is a matter of flexibility. So there is another question. So people who's using Windows subsystem for Linux, so do all commands work the same way on the Windows subsystem for Linux? The answer is yes, because the thing that you run when you're using this trick that Microsoft is doing is you're basically running a Linux distribution inside Windows. So it's basically a virtual machine. It's not, but it's basically that. So the program that you're running, that is basically called bash, that is the one that runs on the terminal, cannot distinguish that he's Windows or Linux. It's just, so for the purpose of the shell, it's like you're tricking the program, and the program thinks it's Linux. So basically you can safely copy paste any commands that you see for Linux on the Windows subsystem for Linux, and it should work. And if not, it's because Microsoft is not doing something properly, but it's basically the same. So one thing you need to know is, this is important, that we won't teach you everything about C++. So C++ is a big language, it's amazing, but it's complex and it's big. So I would say that if you really want to learn everything about C++, like for real, you probably need 2 years, but this is if you really plan to be like a C++ full-time developer. Learning the basics and the core techniques, I think with 6 months it's okay, but of course you need to keep in mind that we can't teach you everything about C++. And of course, if you have any ideas, feedback, or like all your questions during this course, will make this class more fun for everyone else. So maybe you say, Nacho, when I was blah 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 doing this project, we used this other feature of C++ and I think it's better. And this is really good, because then we can discuss like this feature if you think it's better. So it's really impossible for me to teach you everything about C++. One, because I don't know everything about C++, I think no one knows. And then because it's going to take forever. So keep this in mind. Where we will be writing this beautiful C++ code. So basically you have two options. One is to use an IDE. Of course, the people who knows how I think, this is not recommended at all. This is the worst idea you can do, especially if you're learning. So whenever you use IDEs for learning, this will, of course, it's much more comfortable. Everything is working, but then you will miss all the magic of what is going behind the scenes. And when you learn, you need to know this behind the scenes. So on this course, we will go for the behind the scenes that are actually not that hard. And then you will learn how to work besides an IDE. And then we will use in modern text editor. My recommendation is that you can use wherever you want. We will probably use in Visual Studio Code. So this is a text editor that is modern and it's open source. It's supported by Microsoft and has a lot of cool features. I also have a short explanation of why you should be using text editors and not IDEs on the website, so make sure you check that out. But it's basically, this will give you the ability to learn more, to learn the behind the scenes. Also will give you the flexibility to work whenever and wherever you want. So if you go for like big companies, it's really hard that you will find some of these companies using these IDEs, because the IDEs are fine, but for small project or for projects that are like the scope of the project is not extremely big. Whenever you start like going bigger, this IDEs like Eclipse will just crash, or we need to use like half of your computer, and many other reasons. So again, make sure you go and check it out, the website. And if you have any concerns, or if you have any opinion on this, we can discuss this on the chat, We can make a discussion, say, no, let's use IDEs are much better. I'm quite sure I will have like a lot of arguments to beat your complaint, but I'm happy to discuss this if you need to. Another thing is like there's this guy called Beam that is super hard to use, but my recommendation, if you really plan to build a career in robotics, is that whenever you have time, probably now because of the coronavirus, start learning. It's just a text editor, but the thing is it's super fast to use. The text editor is fast. It's hacky. You will feel like you are working on the 70s, but people still use it nowadays in 2020, including myself. And then whenever you work with remote servers or with robots, you will love the fact that you know how to use Beam. Otherwise, you will be suffering. So you can use text editors on remote machines, but when these machines are not super powerful or the net connection is a bit slow, then you will suffer a lot. So make sure you spend some time learning Beam or any other similar tool if you want. So this is the simplest program that will print Hello World. So this is super easy. Let's go back into the history and let's see the assembly code for this example. Here. So this is the same program and this is the assembly code, and then I missed that one. This is the Hello World for the C++. So basically here, oops. So here you have the line that does all the magic, that is basically put this string that we put it inside Hello World to the standard output, and you know that if this program is running without any redirection, it's going to print this to the monitor. And then this std end line, it's basically saying, okay, print a new line when you end this stream. We will discuss this syntax and these double dots starting next week. For now, this is the very first program you will see, and believe me that this is a lot. So actually, when you start, for let's say that you're working with a new robot, and then you have a new embedded Linux board, whatever. So making these Hello World examples just to run sometimes takes months. So Hello World example, it's super simple, doesn't do anything really fancy, but it's a lot actually. So let's build this. Let's build this example. So for that, I will open a terminal, and then I will go to the examples, for example, and then I will create a new directory, and then I will call it Hello World example. And then here, my recommendation is that, so I have seen people using text editors like an IDE. So the tendency is that people will now want to open the text editor and then start coding. My recommendation is try to do everything from the terminal and then create a separate directory. You know where this directory are, and then once you have your workspace set up, then you open the text editor. So we have this new directory. We will go into this directory. For that, we do cd, and then here we don't have anything, and this is fine. And then we will do code and then dot, right? And then this will open a text editor on the screen on this particular directory. And this is my recommendation, is that you always do like this. Let's close this terminal. And then if you see open editors, there is nothing here. So this is Visual Studio Code with the setup and the recommendations I gave to you on the wiki. Basically, I think you can do new file here, and then just save this file and let's call it hello world.cpp. One thing I really like about text editors that I extremely dislike about IDEs is that here basically you will have the files that are on this particular directory. I remember that whenever I work with Eclipse, you have folders, and these folders are projects, and you also have header files that are from the system, and then you don't know where is what. So here you only see one file, that is this hello world. And then if we want to reproduce this hello world example, this is fun because when you do these live coding examples, nothing works. So let's see. And then you just type include. We will discuss this in a minute. IO stream. And then we will write this function. We call it main. And then we will say, okay, print hello modern. Here we will use people who already knows C++. I'm sorry if this is really boring for you, but we need to go through these small details. Okay, let's save this file. Actually, let's add a comment here and say this prints the output to the monitor. Right, so this is your first program. This is a text file. So if you go and print this, you will see on the paper just text. So there's nothing there still. For this, you need to compile this. And then in order to do that, you will open a terminal. In Visual Studio Code, you can open a terminal within the text editor. Of course, you can open a separate terminal if it's up to you. This is the same terminal, that we were using before. If I do ls, I only see one file. And how I build this on Linux with our configuration, you should do C++, and then you will type hello, and then you can do tab, for example, to autocomplete, and then you just hit enter. This will compile your program, and then if you list the files that are in here, now you will see this new file that is called a.out. That is basically the program, that is the executable. So if I execute this program, you will see hello modern C++, right? And of course I can redirect this output instead of in the screen and say, okay, the standard output, I want to put it here to standard std out. And then you don't see the output, but actually you have a new file here. It's called std out that has hello modern C++, and this second line is basically this guy here, that is this end line, right? Super simple. It's a lot because this means that your setup is working. So this is the hello world of the C++ examples. Something that is important, it's comments. Whenever you write source code, you can add comments. Again, the philosophy nowadays is to write code that speaks for itself and not the comments. So basically, this, whatever follows this double slash will be a comment, so this is completely ignored, and whatever is between these two guys, that is basically a C style comment, will be also ignored. So I will highlight you here the parts of the program that you can actually write whatever you want here and will be completely ignored. One thing I probably forgot to mention is that C++ is a compile language. And what is the meaning of this? It's the same as C. Instead of writing assembly code, we will write a high-level language, and then we will use another program that we call the compiler. But in our course, it's the Clang compiler, but it can be GCC, can be the Intel compiler, the Microsoft compiler, whatever compiler for C++. And then this compiler will turn this C++ code into assembly code. And this is really important because there is a big difference between interpreted language like Python or MATLAB and C++. We will discuss some benefits later on in the course, but one of the big benefits is that you know before you run the program if there is some error on the program. People who already work with Python, they know it's an interpreted language, so they will be executing instructions by instructions, and then if you hit an error, then you realize that you have an error when you hit that line. C++ will compile the program first, and if there is no error, will give you an executable, that is the program itself. And then when you run this, it will run binary code, so you don't know like what is running, it's just assembly code. So if you inspect this program, it's really hard to make a sense out of it. And this is one of the reasons why it's super fast. So the comments are simply ignored. And then about styling, it's super important. And this year I decided to not be that tolerant like in previous years. So we will be using a tool. We will have a tutorial on these tools coming soon, that is called client format, that will format your code. And the idea behind this is that programs are meant to be read by humans and only incidentally for computers to execute. So nowadays in 2020, there's no good reason why you should not follow a particular coding style or a formatting style, because it's really easy. You don't really need to do anything. And it's going to make your code look better, and it's going to be easy for others to read. So don't worry about this. So if you follow my setup on how to set up your dev machine, you already have these tools. And for example, if you see this example, if I try to write like really ugly code like this, whenever I save this program, it will auto format the program, and this is also happening on your machine. So if I do Ctrl+S for save, boom, this is now it's reformatted in a better way. So this is important for me, and it will be important for you, because if your programs, when you submit the homeworks, are not in formatting style, your homework will not pass the checks. We will discuss this later on. And then the last thing we will discuss about this hello world is that every C++ program will start with the main. So this is not something optional. This is not something that depends on Linux or Windows, wherever. This is a fact. Every C++ program starts with main. You're checking a project. It has 50,000 files. You want to know where the project starts, go and check the main function. This is not a function you define, it's defined in the language, so you cannot change the name. You cannot say, you know what, I want that my program starts with the function called Josecito. You can't do this. You just need to use main. So main is a function that will return an error code. Basically on Linux there are 255 error codes, but basically error 0 means that everything is okay, and wherever it's not 0 is an error. So if you remember when we were changing commands with the double ampersand, and I say, okay, if command 1 doesn't give you an error, then follow command 2. This error is basically the return code of the program. And then whenever you hit include, so we will have probably next week a full lecture on build systems. You're basically saying, please give me whatever is inside this file, just put it here. So I will show you how this works. Don't be scared. Because of the content of this file, it might be scary. But this include IOStream is doing something really easy. It's basically going to this file. That if you go to this file, it's this guy, just forget this. It's copy pasting, so I'm selecting everything here, and then this include will be replaced with the paste of this guy. So basically doing include and copy paste the code from other files into your program is the same. There is no difference. But why we do this? Because now this is like not too much source code. But let's say that you have multiple includes, then you will have like all files of 50,000 lines. So of course this is not the best way to do it, but actually if you run this, try to compile this program again, okay, we have a warning, but actually let's remove the standard output text and the program. Nothing is here. Let's compile this, and actually you have an executable, so it's the same. You run this, you have hello more in C++, nothing really changed. So basically make sure that, just remember that whenever you do include and then you do IOStream, you're only copy pasting wherever is on the IOStream file inside this particular file. And then last but not least, if you're really anxious and you want to try out stuff, here's an example on how to work with the channels, the input channel, the standard output channel, and the standard error. Actually, let's write this program down. And my recommendation is that you write this program on your own, and then you play with the examples on of the redirection that is on the slide. So I gave you 4 examples. Of course, there are more combinations you can do, but make sure you run this program this afternoon, this tonight if you have time, and make sure you run these guys and to see an example. So basically, another thing, all the programs you will see on the slides, they are basically, so I built these programs before putting on the slide, so they're always working. So you can like safely copy paste the code from the slides. So let's do the following. Let's create a variable here. Let's call my var. And then let's put a 0. It's a good idea to initialize. And then let's say, okay, give me your best number, right? This will print, give me your best number to the standard output. And then if you check the slide, you will see that the syntax to get input from the standard input is this one. It's the same as the cout, but with the stream operator the other way around. So basically, you will do whatever is coming to the standard input. This means stdc in. Just put it into my var. And then let's print to the error, to the standard error, this is not your best number. And then if we compile this again, so C++, hello world, and then whenever we run this program, we'll get give me your best number. And you say, okay, my best number is 900. And I said, error, this is not your best number. And this, you see both outputs, standard output, standard error to the monitor, because that's the default. But let's say I don't want to see the errors right now. Okay, let's redirect the standard error channel to error txt, and then let's run this. Give me your best number, 500. No error message. Why? Because instead of being redirected to the monitor, it's on this new file that is error, this is not your best number. So make sure you check out this example, and that's it. So this is basically the process of compilation. So we humans understand text, and that's why we write in these high-level languages. My computers only can get machine code that is basically binary code. So the compilation, this process is a translation from the text, that is basically your hello world.cpp program, into machine code. And who is doing this? The compiler, that is another program. Compilers that you can use in Linux are many of them. This year I switched to Clang. My heart still belongs to GCC, that is the compiler from the GNU project. But the LLVM project that is maintained by Apple is doing a great job on tools. So, and I think we need to have better tools in order to work better with C++. I also want to give credits to Igor the Great. So Igor is the person who started this course, and it's an awesome guy, an awesome teacher. So my recommendation that, given the fact that we already have lectures for previous year courses, so if there's anything that you didn't understand from my side, just go and check it out, the YouTube videos from Igor. Maybe you can get the ideas from there. And also I would say that 80% of the slides were made by Igor. So basically we are reusing the slides from Igor. So Igor, thank you very much. And I wanted to give credits to him. This is, some people already saw this video, but this is something I tend to do on my lecture. So every time I'm finishing a lecture, in this case it's half an hour late, so I'm sorry. We have 2 hours, but I wanted to make it 1 hour. I couldn't make it. So the idea is that whenever I finish a lecture, I want to give you a video that I think it's related to the lecture, that is not mandatory for the course. So in this case, it's a TEDx talk on why you should learn how to program. So you can watch this video, you can, it's up to you. So again, I put this here, it's on the slides, you will have it on eCampus. The book you might want to use as reference is the C++ programming language. So it's a really small book, it's like this size. It's like 13,000 pages. It's because it's basically like a manual. It's not like a book to read in the bed. So Jan Storstrup, the creator of C++, is the one who wrote this book. So always there's this is usually the best source you can get. If you want to learn C, I would recommend you to use the Kenyon and Ritchie C book language that is again from the creators of C. In our course, we will use this book. We will, I don't ask you to go and buy it or get it online, but if you don't understand some concepts, it's probably a good idea to go and check it out there. Probably the best reference for any other small question you have is CBP reference. So I put you the link here, so just click it, go there, and you will see probably most of the things you need to know are here. The examples are here, so it's a really good reference. And then that's basically it. So I will give you 5 more minutes if you have any questions. If you have any questions probably on the organization of the course or whatever, we can also discuss this offline. Next lecture will be next Wednesday, same hour, same channel. If you have any recommendation or any positive feedback, I would love to know. This is the first time I'm doing YouTube live streams, so just hit me and say, I really like the live stream. I think Zoom is better, this is better. You can just write to the Discord channel, and then we can try to make the best usage of the tools for us. In terms of task for you, so you have some tutorials that I gave you reference on this slide. The slide will be online. And then also you need to install Linux on your machine or use WSL on Windows. Most of you should know this information, so you already should have everything installed. So actually you can, after this lecture, you can go and check the examples by your own, like the examples we saw on this slide, when I upload the slide. And then for Friday, you can check this Bash tutorial. If you have any questions, we can discuss it on the Discord channel. And next week we will be discussing about build systems and core C++ language, and I will give you the first homework you will need to do.